Hello everyone, welcome back. In last week's video, we saw how to build a networked weather station. If you missed it, take a quick look at it. I will have the link for it up here. So in that weather station, we connected to a network API that provides weather data for a given location with a latitude and longitude. I promise that if you don't have a Raspberry Pi Pico W or a Pico 2W, which is what you would need to connect to the network, if you only have a regular Raspberry Pi Pico or a Raspberry Pi Pico 2 with no Wi-Fi capability, you can still get weather information using these little things. These are called DHT or digital temperature humidity sensors. They come in two different types of packages. In fact, they actually have two different types of sensors. These blue ones, they're called DHT11. They're a little less accurate, but there is also a white one, a little bigger and a lot more accurate sensors that you can get, a little more expensive as well. They're called DHT22s. I only have the DHT11s here. And as you can see, the DHT11s also come in two different packaging. One is the raw sensor itself, and it has 4 pins. Not sure how well that's visible. And the other is a packaged sensor that is put on a PCB with a resistor that is required. If you have one of these raw ones, it's not a problem. All you need is an external pull-up resistor. 5K resistor is what the specifications say, but if your kit has a 4.7K, you can use that. I have used it with 10K as well. Just needs a pull-up resistor across the VDD pin and the signal pin. And there is a one pin that has no connections at all. And you will see that in the simulator. And if you have one of these, that external pull-up resistor is already taken care of in the PCB here. So you do not need to use any pull-up resistor. Just connect one pin to ground, one pin to voltage, and one pin to one of your IO pins. And these things record both temperature and humidity, and you will see how to use that with the Pico library. And what we are going to do is we're going to use the power of object-oriented design to build on top of what we created before and just add the new functionality today. So let's get started. All right, this was our design from last week. Just for a quick reminder, we had a weather station application, and that had an association with the net class, which provided all of the network information, including connecting to an API. And it had also had an association with an LCD display, which is where we were displaying the information. It had a retrieve weather method that retrieved the weather from the network, and it had a show weather method that showed the weather on the display. So you already have some kind of an application. Let's say you are using this class and you are running your application with this. Now, what we want to do is we don't want to mess with any of the code that we wrote last week, but we want to use object-oriented design so that we can continue to use this that we created last time. Let's say somebody gave you code that you're building on top of. This code has already been tested and proven to be correct. Now all we want to do is add new functionality to it. We don't want to make any changes to this. So if in future this person who wrote this code makes updates to it, you could maybe pull that into your source and not have to worry about what changes you had made. So what we're going to do is we're going to create a new class called, let's say, dual weather station. Okay. And what we would do is we will make this class a subclass of weather station. So that way we're going to inherit everything that our weather station already has and just need to override or add any other new feature that we want to do. Okay. So let's see how we do that. So first of all, we will need to attach a sensor to this dual weather station. So we're going to bring in our sensor class. And I have a video on the entire sensor hierarchy that is in my main channel. That if any of you want to take a look at all the different sensors that are supported by this Pico library, you can take a look at that. I'll put a link in the video description as well as put up a link up here so you can review it. But basically, suffice to say that there is a sensor class already in Pico library, and one of the subclasses of the sensor class is called DHT sensor. It actually is a little more interesting because this DHT sensor is kind of a uses multiple inheritance from a temperature sensor as well. I'm not going to go into all of those gory details in this video. We want to keep it simple and say, okay, DHT sensor is a type of sensor and it can read temperature and humidity, and how it does that. You can take a look at that video on sensors if you're interested. But today, what we're going to do is essentially create an association between this dual weather station with this DHT sensor class. Now, what we want to do is we want to add that as an attribute. Okay, so let's call it DHT. And then what we would do is we would add new methods. So there are two operations. Of course, there is the init if you want to use network or if you only want to use local. There are different things you would want to do there. So let's send that as a parameter to the weather station. And then what we would do is we're going to create an operation. So there's a new operation. One of the nice things about inheritance is that this subclass, I can inherit things that are already built into the subclass. So retrieving weather from an API is already implemented in the superclass. We don't have to worry about it. We can just inherit it in the subclass. But getting the local temperatures or local weather is not implemented. So we will say, let's say retrieve local weather, or just call it local weather. Really doesn't need any parameters since it does not need to have latitude and longitude, and we can set the unit. We can put a unit in here as well if you prefer. So yeah, we could, why not? We put the unit in here as well. All right. And what we can, so this is a new one. Local weather is something new that we did. Now, notice that the superclass also has a show weather that is designed to show the weather is, right? And it showed it in two lines and things like that. Well, we can't use it because now we've got two different weathers and we want to kind of show it at the same time. So we want to override this show weather method. Okay, so what we're going to do is we're going to create our own show weather. So this is called overriding. And what that does is when you create an instance of dual weather station, which is a subclass of weather station, so you can use the superclasses methods if you so want. But if you don't, and if your superclasses methods don't really work out too well for you, you just overwrite and create your own. That way, you reuse what you can, you rewrite what you need to do on yourself. So that's the beauty of object-oriented design. So let's take a look at how this code works in the simulator. All right, here is our simulation from last week. What we're going to do is we will make a new copy and let's call it video 11. What we're going to do for this is we're going to add a DHT sensor to this simulation. So let's find the DHT sensor. And as you see that in the simulator, we don't have the DHT11, the blue package, they have the DHT22, which is the white version. No worries, we can use that. Let's put this guy over here. Okay, so as you can see, this is the one that has 4 wires, right? So we do need to have the pull-up resistor connector. So let's just put a VCC to our VCC pin, VSys pin, and there's the data, okay? And see, the third one says NC, that means no connections, and the fourth one is ground. So we'll put the ground pin in one of the ground pins here. Let's just put it to the closest one. You can create a ground bus for it. And what we are going to do is we are going to put a resistor, and we are going to use a 5K resistor or 10K resistor. I'm just going to say 5K. And we will put this in between the positive pin and the data pin. So let's just select which data port point we want to add it to. And we want to put it on pin 15. And what we are going to do is we'll take one of these and connect this to the resistor. And we'll take the other end and put it into VCC. So it essentially pulls it up to the voltage. And that's basically what the specifications say. Now, as I said, if you have one of these packages that already have the resistor in the board, you do not need this pull-up resistor. Otherwise, it's pretty simple. Just add a resistor to it and it'll work. If you forget to use a resistor, will it burn up? I don't know, but that's what the specifications say. So that's what I do in every circuit. I have burnt. That's all the hardware changes you would need. So now let's take a look at what the software will require. I'm going to pause the video now and just write a few lines of code, and then I will show you what I did. Okay, so let's see what we did in this code. Um, what is new here? Well, first of all, we added, as you saw, that we added the DHT sensor. So we need to incorporate the sensor module from Pico library. So I uploaded the sensors.py, and the sensors.py also needs the MPU 6050 as a requirement. So we needed to upload that one as well. Now, also what we would need to do is we are going to import in our main.py, we're going to import the sensors module in there. Now, here is our WeatherStation class from last week, which we did not touch. This is, as we said, that we are extending this. We don't want to make any changes to it. But there are some issues with this code because, first, we are extending, which means we are adding the local sensor to it. Second, the way this code is set up is it requires the network. So it essentially, if it immediately, once we send in the network, it immediately tries to connect to the network. Obviously, if you don't have a network, that is going to fail. So we do need to take care of that in our subclass. So let's see how we do that. So here is our subclass, dual weather station, which is a subclass of weather station. And as we said, that it's got basically 3 methods. Init is its own initialization. We'll talk about that in a second. We have a new method called local weather. It takes a unit, and what it does is it reads the temperature from the DHT sensor and reads the humidity from the DHT sensor and then returns the temperature and humidity as a tuple. Very simple. So that's what we need to do. And then the show weather gets the if the network is available, it gets the data from the network and shows the outside temperature in the top line. And if network is not available, then it shows no network on the top line. And on the bottom line, it gets the local weather and shows the network information, temperature and humidity from the bottom line. So it looks pretty simple so far. Now, there's a little bit of trick in the init itself because we do want to make sure we handle the case where there is no network. Okay, so what we do is we, as usual, this is important, we get the local DHT sensor, and this is how you connect it. You create an instance of DHT sensor, it takes a pin, takes a name, and it can take two. The sensor type is either DHT22, which is what we have right now. If you have one of these blue ones, you send DHT11 over here. If network is available, we just create an instance or of the superclass, call the init method of the superclass, um, and nothing else needs to be done. But if network is not available, then what we should do is a couple of things. We could still try to create the superclass. Hopefully, it's going to do all the things that it needs, but we know that it's going to fail. So what we're going to do is when it fails, we are going to set up the things that we do need. We do need the display, we do need the degree symbol, and we need to show other stuff with the local mode in there. And that's basically what we will need to do. And how do we use it? Well, to use it, last week we just said W equals WeatherStation. This week, all we are changing is that one line of code where instead of creating instance of the superclass, now we are creating an instance of the new class that we created. And that's it. And if network is available, let's run this and see what happens. Now we have a network right now, so network should be available. It will connect and show the IP address, and then it will show the outside temperature on the top line and the inside temperature in the bottom line. Probably should have cleared the screen after connecting to the network, but minor bug. That's why we have a few seconds of blank screen while it's retrieving. And there you go. Outside temperature is 69 degrees, inside temperature is 75 degrees. Outside humidity is 30%, inside humidity is 40%. And in the simulator, we can actually easily change the temperature. Let's say outside temperature is 34 degrees and inside temperature is 34 degrees and humidity is 85%. Next time it runs, the outside temperature is, again, the outside temperature is given by whatever the API gives us. The inside temperature will be the equivalent of about 35 degrees Celsius, which is, I'm guessing, about 100 degrees Fahrenheit. And inside humidity would be 85.5%. Yeah, inside is 95 degrees. Humidity is rounded up 86%. All right, so that's basically how it works. Before we end the video, let's quickly see what would happen if we didn't have the network. So if I can comment these two out and send none instead, let's see what happens. WeatherStation local mode, and it says no network, and it only shows the local temperature. Everything else works fine. It's just simply showing the local. So as you can see, with object-oriented design, you can easily take code that has already been written and you can modify it without modifying it, right? You're actually not modifying the code, you're only extending it and incorporating your new requirements into the code. That's what object-oriented design is for, and this is why I created this channel. Hope this was useful, and we will see you at the next video.